Hi. Sorry?
Azhar.
Azhar. Okay. Sorry, not many people showed up. We'll have to wait for some time. So, मैंने एक नया लिंक शेयर करा स्क्रीन तो यहाँ से ये बटन से ऑफ कर दिया मैंने तो एक बार चेक कर लिया अगर इसमें है तो स्टार्ट कर ये शेयर कर दीजिए
नहीं
सही है ना शेयर कर दीजिए हेलो 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 ये पुश करना है पुल करना है क्या करें स्क्रीन ऑन करें जस्ट स्टार्ट
स्टार्ट कर कोई नहीं, कर
ये मैसेज
सेंड
सर्वर पे कुछ चढ़ा है Okay. Assalamu alaikum. Hi everyone. Um, so we'll start now. It's actually streaming also live. You can share if there are people who want to attend but cannot join. You can share the link. We have shared in the groups. Okay. Um, so yeah, I'll talk about. I'll start with what all we are going to talk about. This is a this is the first session we're having here on AI and machine learning, right? So a lot of people have requested us to keep it very beginner friendly. Okay, that's what we'll do it for today's session. Okay, we'll be having sessions in the future where you can't hear us. You can't hear me. Speakers. Hello, hello, hello. Or hello, 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 hello. Okay. इसकी बैटरी का इशू है पावर ब्लिंक कर रहा है So wired line. Hello, 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 hello. Am I audible? Yeah. Yeah. Okay. Yeah. Really sorry about this. Anyways, so what I was saying was we're having this session on AI/ML for the first time here. So this is the first session. Okay. So we'll keep it to introductions, and also I think we're starting a little late. Yeah. So, but I want to give before I talk about the introduction and what I want to talk about the basic things about AI/ML. I'll give a overview of what all is there and what all we'll cover in the future. Okay, fine. Point number one, I want this to be interactive because the more interaction you have, the more you will get out of this. Okay, I hope you have come here to get something out of just maybe 2 points, 3 points, whatever. You will learn something, right? You've come here to learn something, and I want you to learn something that you can apply wherever you're working. Okay, whichever field you're working. AIML is such a what do you say, widespread thing right now that you can use it wherever, whichever field you're working, right? So I'll ask you questions and you'll have to answer. Okay, we'll not move forward if nobody answers. Okay. Um, and by the way, some of these talks are uh, designed for college students, and I give talk to college students, so I've made them interact. So I think I'll be able to make you guys interact. In general, there are okay. In general there are few major tasks in machine learning. Okay, we'll talk about what these tasks are, but I just want you to take a look at this and just see the terms. How many of you have heard of these terms? Regression, classification. Anybody who has heard? You have heard? Anyone else who has heard of these terms? How many of these terms have you heard? All of them, some of them, all of them, many of them, right? Density estimation, dimensionality reduction, clustering, recommendation, forecasting, vision, language, which is actually popular now, reasoning. You guys have heard of these things, right? These are major tasks in machine learning. Okay. There are a few minor tasks. These minor tasks are basically before we do any major task, we need some of these things. We use these things to process our data, to make our data better, get it ready for the major tasks. Okay. Things like scaling, encoding, missing values, classing values. There are many other things. I just mentioned a few of them here. Um, there are a few machine learning algorithms. Okay, so each of these is whatever I'm showing to you is a 2 3 hour lecture. Okay, each of these topics is a 2 hour 3 hour lecture on its own, which we'll be having in future. Okay, this is the first session. We kept it short, but in future we'll have a whole session on regression. We'll have a whole session on classification. We'll also um, see what do we want to get out of this, out of these sessions is just enough understanding that you have a mathematical intuition behind these things, so you can apply it wherever you're working. Okay. Um, each of these is again more than 3 hours. We might have 2 3 sessions on each of these topics. There are probabilistic models, there are general linear models, there are neighborhood models, tree models, SVMs, ensembles, neural networks. These are things that we are going to cover in future sessions, not today. Okay. There are a few extra topics that I talk about. Explainable AI is a completely different field. As our models are becoming more and more complicated, getting value out of them and trying to understand why they are making certain decisions is becoming difficult. So explainable AI, XAI is called, is an entire field on its own, which helps us understand why a model is behaving in a way that it's behaving. Okay. History of AI is about 2 hours of session on how everything evolved. We'll discuss a little bit of history today, only what is relevant, what is important. But um, some people are interested more in how things happen. Why do we do things the way we do today, right? So we have a whole session on that. And this is my favorite topic actually, limitations. I love talking about limitations because people don't know what are the limitations of AI. People actually assume oh AI ये कर लेगा वो कर लेगा सब कर लेगा AI, ठीक है? But that's not the case. There are a lot of limitations on AI. There are a lot of things that AI cannot do. Okay, so we'll have, I think the next month, the next session we are going to have on limitations of AI. Okay, these are some of the best books that I refer to even today. Um, some of these books are course material for more than 500 universities. Like the last book, they dive into deep learning. All of these books are available for free access. You have the URLs here. Um, so these books are free and they are amazing. Okay. So today, what are we going to talk about? We are not going to talk about all these things. Okay. We are going to talk about introduction. Okay. And no better way of starting an introduction other than why do we need to learn AI? So I want answers from you guys. Why? I mean, you guys are here. That tells me something. You guys are giving me feedback that you know that you have to learn AI. But what are your reasons of learning AI? Even from the sister side, you guys can answer. Why are you guys here? First of all, why do you think you should learn AI?
It makes my work faster.
AI makes your work faster. Excellent. Anything else?
How we can apply AI in our day-to-day life.
How we can apply? You want to learn how to apply AI in your day-to-day life? Okay. What else?
Don't learn, you'll be left out.
Excellent. If you don't learn, you'll be left out. Yes. Very good answer. What else? Okay. Anything? Okay.
Sometimes I may miss something, right?
Yeah.
Then I do some mistake. Like, why I use AI right nowadays is to write emails and all, to check grammars, etc. And also for few things, if I don't have an answer or I'm in nothing in that particular, there are many ways of thinking to get a solution, right? So with AI, I can get a holistic picture, and I
Okay. Okay. So
it is scaring to cut the jobs.
yeah. So you're scared that you'll cut your jobs. You want to understand more. Yeah. Why are you guys here?
We can learn more and help us learn things which we want to. It can help us learn how to make apps and other things.
Cool. Amazing. This guy wants to build apps. That's why he's here. Okay. So uh, okay. So I have a very simple answer to this. Some of it which you guys covered. You guys agree we are surrounded by machine learning algorithms today? Does anyone think we are not surrounded by AI already? Like some of you mentioned that we'll be left out. AI is the future, but I disagree with the idea that AI is the future because AI is already here. How many of you think that we are surrounded by machine learning? I'll just give a glimpse. Okay, uh, Chat GPT. These are statistics from last month. 800 million weekly active users. Okay, all over the world. 800 million people are actively using ChatGPT. ChatGPT here has about, I think, 62% of the market share. So overall, the people depending on LLM kind of applications every day will be upwards of 1 billion, 1.3 billion. Okay, billion with a B. Um, ChatGPT has 1 billion queries per day. Okay, so we depend on ChatGPT every day. We all know that. Many of you also mentioned that, right? Every time you use a search engine, you are using AI, and this is not something new. Um, when a lot of you use the word AI, a lot of us actually are talking about a very small part of AI, which is the LLMs, right? But AI has so much more than LLMs, right? Even 10 years back, when you were using Google to search something, Google was using machine learning algorithms to make the search better. Okay, 15 years back, how much ever back you want to go to the start of the internet. They were using machine learning algorithms to index the internet and find what is relevant. Okay. Uh, Many of you have these personal assistants, Google Home, Amazon Alexa, right? They use machine learning algorithms through and through for your speech recognition, for understanding what you're saying. Okay. Every time you look at your phone and it unlocks because of looking at you, it is using machine learning algorithms in the background to open, right? Anytime you are on a social media app, you're doing doom scrolling, Instagram, Twitter, whichever app, the the algorithm that decides which post to show next is actually a machine learning algorithm that deciding what post to show you next, right? Any entertainment system you guys are using, whether it's Netflix or Amazon Prime or YouTube, the recommendation page that you see, right? All the recommendations are built using a machine learning algorithm, right? Most of you are aware of these things, right? Anytime you are shopping online, Flipkart, Amazon, Shopify, whatever, whichever website, the recommendations you see, right? They are they are generated using machine learning algorithms. Have you guys seen these robots? Anytime you order from Amazon or Flipkart, there are these robots running around in their giant warehouses who are, moving things around, putting things in places. Okay, so we don't know this, but in the warehouses, a lot of automation is already happening, right? The speed cameras that are there on the roads that look at our number plates, that ability. How old is that? Does anybody know? I am seeing that since maybe more than 10 years, right? And that works on machine learning algorithms, computer vision, open character recognition, things like that. Most of the industry, manufacturing industry, has been automated. There are these robots who work. Uh, the entire logistics industry actually works on these belts, automated belts, who have this ability to scan and to decide where a certain parcel or a object has to go, and it happens automatically. Every time you apply for a loan or a credit card, there's an algorithm that's deciding whether you'll get the loan, you'll get the credit card, how much should you get, how much should you not get. There's an algorithm deciding that today. This is all happening today, by the way. This is an amazing map actually. So these are all the places where robo taxis are currently working, and these are all the cities. All the pink cities are in China. So there this many cities in China who actually have robo taxis commercially available, being used by people. Okay, and all the purple ones are in US. There's one small green city, Abu Dhabi. Recently, they also got V-Ride commercially starting operations. So this is happening, right? Robo taxis where there's no driver. Um, Food delivery by drone is just part of daily life in Shenzhen actually. So it's a normal thing. They order on, like we order on Zomato. They order on their app, and a drone comes, and the drone that is flying by on its own. Nobody's piloting it. This is a recent news. Himachal is going to use face recognition for Aadhaar distribution. Okay. Uh, Again, just this year itself, in February, uh, there's a hospital in US that uses AI technology to detect lung cancer, and the doctors of that hospital depend on the results from the AI to, concur their own results, their own understandings. Uh, there's this amazing article on the Quint which talks about there are these algorithms that decide whether you'll get hired or fired. Okay, and this is happening a lot in the industry now. There are these machine learning algorithms that deciding whether you should get hired or not. In fact, a lot of these resumes for the first screening they go through these AI apps. This is a very recent news. How a robot performed surgery without human assistance. We have had robot assisted surgery for a very long time. Even in India, there's a lot of hospitals who do robot assisted surgery. But now we are coming to a different time period where you don't need a doctor to do the surgery. So now do you agree that we are surrounded by machine learning algorithms? It's AI is not the future, AI is already here, right? So my next question is, so what? So what if AI is everywhere? Do you guys get this question? So what? I mean, you'll always have easy way to access AI, right? You'll always have some kind of tools that internally uses AI, but why should you know AI? What do you think? Have you heard of this digital arrest scam that happens a lot? Uh, there are some people in society today who are vulnerable to these kinds of things, who are vulnerable because they have less information of how the digital world works. Okay. Um, you know how elderly people also struggle with digital technology, and you know how if you don't know much about the legal system of a place, you are vulnerable to abuse of power by the law, actually, by those who have power. There's this whole movement by International Labour Organization and United Nations to know your rights. Your rights are your superpower. If you don't know your rights, if you don't know the legal system, if you don't understand the legal system, you are vulnerable to being abused. Okay, so there's this idea that in a world which is dominated um by digital communications, and a world which is dominated by laws, your ability to be competent and your ability to protect yourself depends on digital literacy, right? Depends on legal literacy. Okay. And the reason why we want people to know more about AI and learn AI, and the reason I want you to learn AI is because of this thing now. Because we are surrounded by AI already, and we are looking at a future where just imagine if all these things are happening already in future, there are chances that our lives will be dictated by some algorithm every single day. There will be an algorithm that decides what you watch, what you like, what you don't like, whom you vote for. There'll be an algorithm that it already happens, by the way, but it's going to even you know, be more widespread and cover more people, right? So essentially, this is my argument why we should learn about AI. Now, one question that comes is how much should we know? What do you guys think? Should everybody do a PhD in AI? How much should we know? What do you guys? How much do you want to know? How much have you come here to know? Would like to know that also. Any answers? To the extent to survive. Excellent. Um, do you know how much you have to know to survive? Okay, so whatever applies to your field, you should know that much. Any other answer? Someone thinks otherwise. I think this is all I want to say. I think everybody has to have an intuition, and that intuition tied to a little bit of mathematics, that what AI is capable of and what AI is not capable of. Okay, if you have that intuition, and see, a lot of times our intuitions are wrong. Okay, if it's not grounded in something. In AI, the language of AI is actually mathematics. Okay, the language of AI is mathematics. So I believe everybody should know only enough, at least just enough, to develop that mathematical intuition. Okay, and in these talks that we're going to have, I'm going to focus on this. I'm going to focus on helping you guys develop that intuition that somebody says. I mean, I don't know if you guys face this, but I face this a lot. Uh, in our company, someone says, "अरे ये AI से हो जाएगा." कैसे हो जाएगा भाई? What are you saying? I mean, सब कुछ तो नहीं हो सकता ना. People nowadays have this, "अरे ये AI से हो जाएगा." But unless you have that mathematical intuition, which people don't have, which a lot of, especially the leadership, doesn't have, that leads to problems because they don't know what is not possible with AI, right? Right now, I want food to be cooked by AI. Can you do that? Huh? No, I want it right now. My food to be cooked by AI. I mean, the people are attempting to do that, but there are limits, right? I want an AI right now to come and stand near me. It cannot do that. Right? There are some limits, so we have to understand the limits. Um, okay, so so that's why we need to learn AI. That's why everyone needs to learn AI because of AI literacy. Okay. Now I'm going to talk about certain terminology. Okay, that is absolutely essential. Okay. Whatever is not essential, I'm not going to talk about. But I'm sure you guys have come here to understand a little bit of terminology. What is this? What is that? Right? So before we start, even before we start, what is AI? The first question is what is intelligence? What is intelligence?
Smart.
If you are smart, you are intelligent. Okay. What is smart?
Ability to make smart decisions,
Ability to make smart decisions. Anything else?
reasoning, prediction, logical reason,
Logical reasoning. Okay. Prediction. The ability to make predictions. Very nice. Okay.
Knowledge. Knowledge that you have to know.
Okay.
I mean, machines.
Okay. Let others answer. Yes. Intelligence. Anything. What do you think is intelligence? I mean, you have come here to understand artificial intelligence.
ability to think,
Ability to think. Very general. Okay. Nice.
Knowledge. How much you know?
Knowledge. How much you know. Okay. Knowledge is different from intelligence.
ability to analyze and use what someone is asking for.
Good, good, good. Ability to analyze. Asking.
Questions.
Ability to ask questions. Maybe. Yes. What else? Okay. I have a few definitions by psychologists. Okay. Let's go through them one by one. Um, Intelligence is the ability to judge well, reason well, and act well. This, by the way, Binay. These are all psychologists. Binay is one of the guys who actually gave the foundational ideas on which IQ test is based. Okay, so these are not small psychologists. Intelligence is the global or aggregate capacity of an individual to think rationally, act purposefully, and to deal effectively with his or her environment. Intelligence is the capacity to learn and adjust to relatively new and changing conditions. Intelligence is the ability to adapt, to shape, and to select environment to accomplish one's goals and those of one's society and culture. These are broad, very general definitions. Now, try to look at these definitions and try to look at what you think of as AI. Try to think of ChatGPT, or do you think this applies to ChatGPT? I'll give you one more definition. This is by Richard Yonk. He's a guy who actually works in artificial intelligence. He says an emergent system's ability to respond to its environment in order to improve its conditions, perpetuate itself, and maximize its freedom of action. He has added the ability to perpetuate itself. We are intelligent and we have the ability to perpetuate ourselves. Do you think this applies to ChatGPT?
Yes.
No, it doesn't. Do you think ChatGPT can perpetuate itself? So, um, to be able to build artificial intelligence, people actually redefined the definition of intelligence and made it simpler. Okay, we cannot we are nowhere close to building things that can do all these things. Do you guys agree? What do you guys think? Do you guys agree this is like too complicated for us to create right now? How do you perpetuate yourself unless you're a biological organism? Think about it, right? So this is a simpler definition, which is a lot of people, you also talked about the ability to learn, the ability to recognize problems, and the ability to solve problems. Okay, and most people in the AI industry agreed that let's consider this as our definition of intelligence: the ability to solve problems. Okay, so now what is AI? Now you know what is intelligence. What is AI? Yes, an attempt at mimicry of whatever we discussed right now. Okay, that's it. Simple definition. AI is an attempt at mimicry of human intelligence. Okay. Uh, Now we are making an attempt, but how much? What is the level of mimicry we can do and we have done? You guys must have heard of these terms like AGI. Have you guys heard of AGI? Did you guys understand what AGI is? What do you think AGI is?
like human
Very similar to human intelligence, something that comes close to human intelligence. Yes. So there is something known as artificial narrow intelligence. Okay, where you have these your intelligence is able to is performs well on a certain task, not beyond it. Okay, whatever it is defined, it does good at it. Artificial general intelligence is when something, an application, can perform across tasks. Okay, it can do it can perform well not just on one task but also on the other and the other and the other. ASI is super intelligence, which is something that is even more intelligent than us. We are trying to mimic human intelligence, but imagine something that is even more intelligent than us. Now, what do you guys think? Where are we right now with ChatGPT and the best model of ChatGPT?
yes.
Hmm?
So between ANI and
Okay, between A and I and AJ. Okay,
Yes. AGI and ASI.
so there are people who are saying ASI. Okay, there are people who are saying between A and I and AGI. What else?
And ASI.
Okay, anything else? Okay, I'll let you guys decide. This is ChatGPT's second best model, right? You all of you must have heard of this. If you have a model, an AI system like ChatGPT, which supposedly is able to crack PhD level questions, and if it doesn't answer this, do you think a PhD guy will not be able to answer this? Is there a PhD person in the whole world who, if you ask how many R's in strawberry, it will say, I don't know, maybe two? Is there a person? Can you think of a person who will answer this? You know what it's doing, right? It's unable to count the number of R's in strawberry. This is the second best model, by the way, right? Okay. And even when the latest model came, I don't think this is accurate, but this was made as a joke on ChatGPT. Somebody asked how many strawberries are there in the word R, and it says the letter R has three strawberries. Okay, it completely got it wrong. So now, what do you think? Where are we? Now, people who are thinking ASI, something that is smarter than humans, or people who are thinking we are somewhere close to AGI, what do you guys think now? Huh?
ANI.
We haven't we haven't gone past ANI. We're still developing systems that are only good at certain tasks. If you have an LLM which you claim to be able to write code and PhD level questions and pass IIT questions and pass medical questions, you've heard of these things, right? These claims that ChatGPT can do all this. If it could do all that, but it cannot count the number of R's in strawberry, what does it tell you?
that's what it was confusing because I personally also have tried it and also I've heard a lot of things related to ChatGPT because for us AI is something ChatGPT, which is easily accessible like something how Google was before.
Exactly.
But sometimes it gives you very, kind of to an extent, a very good logical reasoning. And then sometimes it gives you very weird kind of answers or responses. And even the data in ChatGPT, I believe it's not up to date like previous years or like 2024, 23 back data. So I'm not able to
So,
understand
yeah,
you can completely trust it on the answers what it provides. And
exactly.
there's one way where you see, especially in China, you've got things like they're developing like robots. They're planning the robots to be like a human. They're planning, it will think on its own, work on its own, take decisions on its own. So it's pre-created it, but it has that ability. What you say. So where do we stand now? That's the
See, most people have this doubt, and that's why I have a whole talk on limitations. And I want to discuss this exact point in the limitations. Okay. Um, I will actually answer your question very briefly right now. Uh, See, people are realizing now that first of all, we don't know what the model is thinking. What is happening inside, we don't know most of it. Okay, people are trying to, the researchers are trying to um, zoom into it and try to find out how it's thinking. Okay, and the way they do it is they build plots of the weights that are there inside. If you can understand some of it, what I'm saying, they look at the plots, they look at loss curves. Okay, and they try to understand what it's doing. There are researchers who believe there is no comprehension and no understanding inside that model. Okay, there are researchers who think that it's able to understand, it's able to comprehend. Okay, but there is large majority of researchers who says there is nothing. Okay, in fact, we'll talk about this. You'll understand where I'll actually discuss this in future, that why sometimes you get impressed by the results and sometimes it just behaves weirdly and awkwardly and says things like there are 2 hours in the strawberry. Okay, we'll do this. So you guys agree now that we haven't crossed ANI. Okay, and in fact, if
But there are a lot of research happening in India we are not still exposed to, right?
there's definitely a lot of research happening to build AGI. They want to build. They're doing all kinds of attempts to go there, but you see things like this. You see things like where you create a system that should be capable across tasks, but it fails across tasks. What ends up happening is it becomes very good at certain specific tasks. So even ChatGPT internally is made up of multiple models. Okay, and when you have multiple models, and when there's another system that's deciding which model to use, it's difficult to say whether it's one model who is doing cross task thinking, because it's not. It's multiple models. Okay, but someone can say, oh, as a whole system it's at least able to do that, but it's not able to do that because these things, especially cases like these, are patched up using heuristics. There are heuristic algorithms that run, that look for these kinds of things, these kinds of anomalies, and they give you the correct answer based on that. Do we think do human beings are intelligent in that sense? Do we make suppose a PhD guy will make a silly mistake like this and then he'll have to relearn how to solve a smaller problem? Or when we are intelligent throughout, right? So that's the thing. When we say AGI, as you said, AGI is something that is close to human intelligence, right? And humans are not intelligent like this. Humans are intelligent in a different way. We are intelligent in a way that when there is a person who is intelligent, you don't expect them to make such mistakes. And then you don't say, oh, it's okay. Now you can learn how many hours are there. And next time, maybe you don't. We don't do that, right? But we do that with, and that tells us something, that there is something lacking in the LLMs. Okay. We'll talk about LLMs also.
Can we say that these AIs are partly there, be it super intelligence or human intelligence or this narrow intelligence? Partly they are there because there are some capabilities where they're exceeding human intelligence in certain areas, and there are some capabilities where they're exceeding in certain
Yeah, so
AGI.
see, when you're able to build a system that exceeds human beings in a certain task, we don't call it intelligent. You know why? Because can you call a calculator intelligent? Because it exceeds in one thing. We cannot do the computation so fast. It can do that, but can you call a calculator intelligent? That is the definition of intelligence. If you build a system, so this work is called broadly called expert systems, and these expert systems we have been working since the 1960s and 1970s. We have built a lot of expert systems. In fact, Deep Blue, which came in 1997, was able to beat the best chess player in the world. Um, some people will call it intelligent, but will you use the word AGI for this, or will you call it as intelligent as a human being? It's able to only, that's all it can do. So in that restricted sense, you can call it intelligent, but will you use the word intelligent for that? Most people will not. It's a system designed to beat people in chess. That's all, right? So we don't define intelligence in narrow way, at least not for human beings, and not generally also, right? So why should we define it specifically for these systems? Maybe IBM engineers who build that system till today call it intelligent. Maybe this, they do that, right? But that's a bias, right? You wouldn't do that for normal people, so why should we do it for a specific system? Okay, so now we have some idea of artificial intelligence. We have an idea of intelligence, right? What is machine learning? Simple terms.
Ability of the machine to learn through data that is subjective and make some intelligent
Okay, link it to what we have discussed till now. Machine learning.
Training a machine with data.
Okay, that's fine. That's fine. But I want you to link it to what we have discussed.
train the machines with the problems actually. It's perform the activities and then learn the machine.
Okay. Okay. See, all of you are right in some
Learning
sense.
how to see first and how to make it better.
Okay. Good. So, see, machine learning is just the process to make a computer intelligent. That's all. Okay. Uh, this is one of the things I see that people have compartmentalized these terms, and AI is something, ML is something. ML is the process to create AI. That's all. The process which you use to say I have a machine, I want to make it intelligent. What is that process? That process is machine learning. In fact, this is not a the terminology is not, it's not weird actually, because how do you become intelligent? What do learning exactly, right? So we become intelligent by learning. Machine will become intelligent by machine learning. Simple. But obviously, for the scientists, it's not simple. There are some definitions given by the scientists, and I don't want people to go back and memorize these definitions and see that, oh, we saw a lot of definitions, but there are some intuitions in these definitions that I want people to start gathering. Okay, even for our future discussions. A computer program is said to learn from experience E with respect to. In fact, read it. I want you guys to read it once. Tenth. Oh yeah. So you see three things here, right? There is T, there is P, and there is E. Okay. So at this point, I just want you guys to take this. Just remember this. There is T, there is P, there is E. There is a task. Okay. There is a task which you want to become better at. Okay. So there should be a way of knowing a measure of whether you are getting better or not. Okay. And to get better, you need to have some instrument, some device, something that helps you get better. That thing, that device is called experience. We also get better by experience. Okay. And experience for computers is, we'll discuss this probably more in detail later, but it's just data. Experience for computers is data. Okay. This is another definition. This is slightly simpler. The field of study that gives computers the ability to learn without being explicitly programmed. This is extremely important. The definition is slightly simpler, but it has a lot of meaning inside it. without being explicitly programmed. Can you guys relate to what it's saying? What does it mean by explicitly programmed? Does anybody has an idea of what it means?
Yeah, I mean, no specific instructions to learn nothing, but ideas to grab the information without giving a specific instruction.
Without any specific instruction?
Addition to existing.
No more addition to existing data. Hmm, not really. Anyone else?
Within in one shot, it's
One
completed.
shot. No. No.
Okay.
No. No. Anything
Predicting
else?
based on the existing, like kind of a prediction based on the existing learned data.
Sorry.
Like machine learning model which learned by like a data set that it want to predict on any based on
Okay.
previous learning.
That's fine. But what does explicitly program means?
Traditional algorithm like we define the things right, what to expect, what is the input value. Instead of that, we learn with some data sets and the outcome can predict on a new data.
Okay. Some of you have an idea and some of you don't. Okay.
Whatever the function, whatever the code we are adding extra in particular function, that is called as
Mm, extra code. No.
extra thinking,
No.
additional.
No. Anyone else want to try?
Process the plain data.
Sorry.
Process the plain data. Should be able to process the plain data.
Plain data. Mm, no.
Process of learning is influenced by the data itself, input that it takes.
You are very close. Okay. Okay. We'll discuss this. Okay. See, this is the final definition that I want you guys to remember of machine learning. All this is there. All that is true, but history has taught it a very simple definition of. And I want you guys to um, from this session go back, have something useful for you. Okay. See, if I just gave you these definitions by these people, you will not remember it. Okay. This is the simplest definition of machine learning: finding patterns. That's it. Are you able to relate? Are you able to connect? So machine learning is the process to become intelligent. What is that process? It's finding patterns. It's learning. What is learning? Finding patterns. Nothing complicated. Okay. So we'll again touch upon the idea of explicit programming. Okay, and you'll see why it's important. Um, See, this is a normal program. Okay, this is something that we have been building for maybe 50 years, 60 years, right? This is how we do all coding. Okay, um, you have an input and you get an output. Okay, and other than the input and output, you also have a business logic or a math formula. Okay, suppose there's a simple application that converts Fahrenheit to Celsius. You have a small program. That small program has the formula, math formula for converting Celsius to Fahrenheit. And you give the input, you give Fahrenheit, you'll get Celsius. Okay. Think of any application that we have built in the software industry. Any app, all of it works on this logic. You have an input, you have an output. You have a web page. You click on it. The input is the click. The output is where you should land after the click. How is it decided? There's a logic behind it. If you click on this, you should go to this page. If you click on this, you should go to if else rules, business logic, math formulas. All this is basically is what I'm calling it pattern. Okay. So you know the pattern, right? Something that you were talking about. You know the pattern, and if you give an input, you'll get an output. This is how software industry works. But there's a small bit of history I want to talk about. Do you think where did we get this idea by the way from? How did we come up with this kind of model? The whole software engineering industry. In fact, this is something that most people don't know. Um, in the 1960s, right, there were people who were working on AI. People like Turing. You guys have heard of Turing, right? People like Claude Shannon. People like John MacArthur. Okay, um, and a lot of their colleagues. Many people, some of them are considered as the fathers of AI. And what they thought actually at that time was that this is how the human brain works, and they were trying to replicate the human brain. They wanted to build an intelligent system. Okay, so in fact, if you look at the history, there is AI is something historical. Okay, it goes way back. Okay, there was uh, there are people, there are philosophers who are talking about AI at the time of BCs. Okay, this is a famous point. In fact, I have all this discussion when we do a whole session on history of AI. We'll talk about this. But a book written in 700 BC by uh, by a Greek author called Homer wrote a poem called the Iliad. People who are interested in art and literature, they must have heard of this, the Iliad by Homer. He talks about robots and AI and things like that. So philosophers have been talking about AI. There are these people who are statisticians who have been working on AI since very long time, from 1600s. Okay, uh, you've heard of Gauss, you've heard of these astronomers Kepler. They had all these data, and in fact, you saw something known as general linear model in one of the, I mentioned, right, one of the types of algorithms called general linear model. One of the most basic algorithm there is called regression. Regression was invented in 1600s. People were looking at the data from planets, observing the planets, and they used to build a simple algorithm that would be able to predict where the planet will be in future. Okay, so this was all being done. So the field of AI actually comes from multiple disciplines. There were philosophers. Okay, it comes from philosophy. Okay, philosophy. There is statistics, and one of the first people who were working on statistics are statisticians and gamblers, people who used to gamble. AI has a big history of people, gamblers contributing to AI. So people who were gamblers who wanted to get good at gambling learned mathematics because they realized it's not just all random. There's a bit of maths behind it. There's a bit of science behind it called probability. So they learned mathematics to get good at gambling. There are mathematicians who realized they were very poor. They wanted to make more money. And so they went into gambling, and they could make a lot of money because of that, because they knew mathematics. So mathematics, gamblers and statisticians contributed to the field of statistics. There is contribution from neuroscience. Okay, this pen is not amazing. Neuroscience. So neuroscientists were trying to understand how the brain works. Okay, and all of this came together around the time of 1960s and 1950s, and we got this idea of artificial intelligence. One of the first conferences on artificial intelligence happened in 1965 or something. It's called the Dartmouth Conference, and the people who organized the conference are actually today called the fathers of AI. They were the people, okay, but they developed something that we nowadays it's known as symbolic AI. Okay, they developed this field called symbolic AI. Symbolic AI is dead. Is dead. Nobody works on symbolic AI. But it was AI in the 90s till 1990s. The deep blue that I mentioned, that one chess was actually built using symbolic AI. At that time, they were also trying to create new fields called machine learning and new fields called deep learning, neural networks. Okay, and one of the people who founded, so one of the people who attended the conference was also this guy called Marvin Minsky. He is the one who created the AI lab at MIT. Big guy, okay, not a small guy, big guy. The lab, AI lab at MIT, okay, was created by this guy, Marvin Minsky. He believed in symbolic AI and he made fun of deep learning. He wrote a book called Perceptron in which he made fun of neural networks. He said neural networks are useless. Nothing will happen. Don't waste your time on neural networks. Today, we know that neural networks are building the most advanced AI. Symbolic AI is dead. The thing that Marvin Minsky and John McCarthy and all these people who what they were developing is dead. Nobody uses them. Nobody even talks about them. But from here came a whole new field, and this field is called IT and software engineering. So IT and software engineering, this idea of traditional program actually comes from these founding fathers of AI. They were not trying to build softwares. They were not trying to build how to build websites or how to. They were trying to build AI. They failed at AI, and they gave us this entire industry of IT and software engineering. So now this is something you need to understand that this this sort of traditional model, the way we do software engineering all over the world, was a failed attempt at AI. Okay, but the entire software engineering the industry runs on this, right? When you do Java, when you do Python, when you do C++, when you do whatever language programming you do, it's all doing this. It's all running on this. Okay, but as I mentioned, people then started looking at other fields like machine learning, like deep learning. So they started thinking that maybe human brains don't work like this because you're expecting the business logic and the maths or the rules to come from outside, but we are able to learn patterns inside our brain. Nobody's telling us what are the patterns. We can find patterns on our own. So most likely human brains don't work like this, and most likely intelligence will not come like this. Again, Deep Blue was able to defeat in chess using this. Now will you call it intelligence? It's not even using the same models of building intelligence that we use, right? So we created a new system of what people realize that I actually need a way to get the pattern. I don't know the pattern. I don't know the rule. I don't know the maths formula that's run. So what do we do? So this is all it does. This is all a machine learning program does, and this is how it's different from a simple program. In a simple program, you have the input, you have the pattern, you enter it in the program, you get the output. But now you don't know the pattern. So what should you do? So we build a technique, a system that where you give the input, you give the output also, and it will give you the pattern. Okay. Now, what is Gen AI? I'm sure most of you came here to understand and differentiate machine learning and Gen AI and AI.
Chennai is just a prediction of what comes next. It's simple, simplest of.
Right? You're right. But this definition also applies to machine learning. Machine learning is also generating a
Only
prediction.
addition is like the way you converse with it in your human language.
No, actually, it's fundamentally different from machine learning. Gen AI is fundamentally different from machine learning. So we saw normal program, we saw machine learning program. Can you guys relate how a Gen AI program would be functioning based on this kind of setup? What would be happening in Gen AI?
The pattern
Giving the pattern as
uh, input and
input. Okay. So the pattern is the input. What is the output? What do you think? Anyone else? Any ideas? So I've told you how traditional programming works. I've told you how machine learning program works. What do you think is Gen AI?
finding the pattern.
Finding new patterns. But that is what machine learning is doing. What is Gen AI?
Basically, AI would be a orchestration of multiple uh, algorithms which follows that second model that you mentioned. Like,
Multiple. Okay, you're saying multiple machine learning algorithms. But there's a fundamental difference in machine learning and Gen AI. Yes, yes, sister.
one is like only thing what I can understand is language part, like just take that language
Gen
and
AI has just as much to do with language as machine learning. You can use Gen AI for images, you can use Gen AI for tabular data. Yes, sister? Can't hear.
Nowadays, instruction and generate the picture.
That is Gen AI. What do you think Gen AI looks like? If traditional program looks like this, machine learning looks like that, what is Gen AI? You're right, it is generating new content.
Feedback, the output feedback between the
Hmm. Feedback. Feedback is an important thing, but it doesn't come here. Feedback has no role. We'll discuss feedback in reinforcement learning. Okay.
based on the labels,
Huh?
on the data labels, based on the data labels, you guys match what what will be the like I'm giving the image of the cat. You try to label find the images to the label cat and it will I mean, generate a pattern and try to match it to the cat.
That is machine learning. That is
it's
machine.
basically a word cloud and it's the levels of words are
No, you have to think more basic. You have to go beyond words and language because you can use Gen AI for other things, as I mentioned. Gen AI has as much to do with language as machine learning. Just like you can build machine learning models for language, you can build Gen AI models for language. But
It's
what
like
is
it doesn't use just the language. It gives its intelligence to generate the output. It generates the output. Not just based on the
something
like
close?
audio
Fine.
and video both are synced together, right?
That you can do for machine learning also, right? That's not fundamentally, but something you're coming very close.
Question is the input and the answer is the
Question is the input, so input is going in, right? Input is
And
the
then it
input,
shows an output.
and output is the output. That's what you're saying. That's a traditional program. Okay. The general idea you are giving is right. Okay. Hmm. This thing applies to machine learning also, what you're saying, sister.
application of this
I think
particular.
if you have to use that
Just
as
one
a
second.
model,
Yes?
It's like basically it's an ML model, but it's application.
No. It's not ML model.
are you saying that the pattern again will come as an input to the model itself?
That's right. You're right. What else? Okay. So slowly people are coming closer. Okay. Now I'll solve the mystery. This is Jenny. Okay. Anything became clearer now, or you became more confused?
Clear.
Does it clarify some things about Jenny? You see how it is fundamentally different? Any confusions with this? There is no input, there is no output. There's just the pattern. Based on the pattern, give me the input also, give me the output also. Okay? Okay. So see, these are the fundamental intuitions I want people. And in fact, One of the reasons why we wanted to do this talk is uh, I actually attended a lot of AIML talks, and I saw that people at high positions, leadership positions, VPs and directors and managers, they're talking about AI a lot. Okay, but at the end of the day, I go through their 1 hour presentation. I'm like, what did he say? Have you guys faced this? Have you guys attended any AI talks? And after the talk, did you feel that, like, wow, at the end of the day, what did I learn? Has this happened?
Sorry, I missed it.
So, so I'm just saying that I actually attended a lot of AI machine learning talks, and I could not get anything out of the talk. Some big guy from some big company, he'll be giving a lecture on AI, and there'll be a lot of terms and there'll be a lot of diagrams and figures, and but there will be a lack of understanding in the speaker and a lack of understanding in the audience. Okay, so that's the reason we started these sessions. Okay, I want you to get the fundamental intuition behind these terms. Okay, and I hope you will be able to remember them as well. Okay, because if it's something simple, you'll be able to recollect, right?
Can you just explain me with an example how patterns we can improve?
Example.
I think
Okay,
I'm not able to get it.
okay. We let me see. Do we have this discussion? Yeah.
Firstly,
Well, yeah, yeah.
we'll educate patterns, and then we'll be into the input.
No, 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 no. All you need is a pattern. All you need is a mathematical formula. Okay. See, simplest example I can give is see, it has to do with probability. Um, GenAI, by the way, is also something very, very old. Okay. GenAI is not new. GenAI has become better now. It was not this good before, but the idea behind GenAI is very, very old. Okay. Simple idea. Maybe you'll be able to answer your question. If you look at the heights of everyone in India, suppose, okay, what will that frequency distribution look like? Something like this. We say that things like heights and weights and a lot of natural properties follow a normal distribution. This is getting slightly advanced, but maybe you will get the intuition. That's why I'm saying, okay. There is a mean age, mean height of every country. India has an average height. That height will be something, maybe 5'4", 5'5", correct? Okay. This is actually what I've drawn. It's what is this? This is the number of people who have the height 5'4", and that number of people will be the highest. You can see there is a peak, right? The most number of people in India will have the average height, whatever. I don't know what is the average height. Anybody knows here? 5'5", 5'6". What is the average? 5'5", 5'6". Okay. The most number of people in India will have this height if you do a survey. Okay. Less number of people will have less height, and less number of people will have more height. But most people will have this height. Okay. This is called a frequency diagram. Correct? Can you understand frequency diagram? Number of people. Here, this number of people. Okay. This can be converted to a probability distribution. Probability means if I divide this by the total number of people I have. Let's say I looked at 1 lakh people. So if I divide this number by 1 lakh, I will get the probability that you select a random person. What will be his height? If you select if you select a random person, that his height being 5'6" is the highest. Why? Because this is the average. Okay. This now, just by dividing it by total, okay, this curve has suddenly become a machine learning model. See, this is a little advanced, but I'm going because you asked the question. What is machine learning model? We were going to discuss this, but this is an example of a machine learning model, the simplest machine learning model based on statistics. What am I doing? I'm counting the number of people who have this height, 5, 6, and I'm dividing by the total. That's it. And I'm counting all the heights of all the peoples. And I got this curve. This is an example of the simplest machine learning model. Now, this is the pattern. This is the pattern that explains heights in India. Okay. If I do something known as sampling, what is sampling? Sampling is nothing but picking a random value from here, but not picking randomly as I wish, picking randomly based on this curve. So more chances of picking from middle, less chances of picking from here. This process of generating a sample is the simplest Gen AI process. We will actually discuss all this in detail in future sessions. We will do that. So some of you may not be able to understand, but in future sessions, I promise you'll be able to understand what is happening here. When you pick a random person from this distribution, you know what you're doing? You're doing Gen AI. Okay. So what am I picking? I'm picking the input as well as the output. Are you able to relate now? I'm picking the random person, what will be his height, and I'm also picking the frequency of that height because that frequency is tied to the height based on this relationship. Okay. I wish I could give a simpler example, um, but we'll see. Okay, I'll try to explain this better. Did it help anyone in understanding Gen AI? Again, Gen AI is something very old. As I said, I literally created a Gen AI model in front of you, the simplest Gen AI model. It's not very useful. That I agree. It's not very useful. It will not be able to generate, how to cook some dish that ChatGPT can do it. It will not be able to do this, but this was the simplest. In fact, we will see how even ChatGPT is just lots of these distributions. We will see that. Okay. So we have an idea of artificial intelligence. What is intelligence? What is artificial intelligence? What is machine learning? You guys remember what is machine learning? Simplest answer.
Process of making machines.
Yes, but what is machine learning? Definition of machine learning. You're right, but the final answer that we
Patterns, identifying.
right, learning patterns, nothing else. Learning patterns is machine learning. In fact, in my college 10 years back, 12 years back, 13 years back, we had a course called pattern recognition. And we used to learn all the machine learning algorithms. They were not called machine learning algorithms. They were called pattern recognition algorithms. In fact, one of the best books, I didn't mention that book because it's a little old. The fourth book, if I had a book to mention other than the three books that I mentioned, it'll be the book by Christopher Bishop. It's called Pattern Recognition. It has all the machine learning algorithms. The name has changed. The algorithms are same. Okay. So now how are these terms related? Let's try to understand it a bit. AI, machine learning, Gen AI. Okay. Now, the only reason I'm showing you this is because this is nonsense. In all the AI talks and machine learning talks, you will definitely guaranteed see one of these charts. Okay. And I'm telling you upfront, this is nonsense. Okay. The only reason I'm showing you is to know that when somebody is giving a machine learning and AI talk and you see this kind of talk and he spends a lot of time on this, you will know that you're not going to get any value from that setup. Okay. So there are a lot of problems in this. They try to make beautiful charts, and AI is the big circle. Inside there is machine learning. Inside there is deep learning. Inside there is Gen AI. As I mentioned, Gen AI can be done using probability. You don't need deep learning to do Gen AI. I just showed you, right? Gen AI, simple example, using probability. Deep learning, this is right. Neural networks are, we'll see in the future, neural networks are a type of machine learning algorithm. Again, you look at this machine learning. and neural network. As if neural network is most of machine learning. That's not true. If I draw a correct picture, it will be something like this. So if this is machine learning, okay, this is neural networks. This is how it should be made, okay. And there is not much difference between neural networks and deep learning. Neural networks is equal to deep learning. Remember that. The only thing is when you have a big neural network, when your network is huge, we start calling it deep learning. That's all. So neural network, big neural network is deep learning. Okay, nothing complicated. And most of machine learning is not neural network. Neural network is a small part of machine learning. There are so many things in machine learning. Okay, and again, AI and as if machine learning is a lot of problems with these kind of charts. This is somewhat more, a little bit more accurate. This is a little bit more accurate. But again, if I would draw it, I would draw it like this. You have AI. You remember symbolic AI, dead AI. So the only AI other than machine learning in AI is actually the dead AI, symbolic AI. It's also called GoFi. GoFi. Good old fashioned AI. Okay. This is symbolic AI. It's dead. It's dead. Nobody learns this. I mean, it's surprising that GATE AI questions, if you look at GATE, right, GATE exam AI questions, they have 80% of the questions are on symbolic AI. Why are they asking questions on symbolic AI? It's dead. Nobody uses it. But see, this is the level. This is the level of how we evolve. Indians, even till today, yeah, the academics of India is still teaching and asking people on symbolic AI. So there are only two parts in AI: symbolic AI, which is dead, and machine learning. There's nothing here. Okay, so again, these kind of figures are confusing. By the way, all these slides are available at my website exube.com. Okay, so if you want to refer to the books, those links, free access links, are available on the website. Now comes the question: what about data science? We didn't talk about data science. We talked about AI. We talked about machine learning, Gen AI. What do you think is data science?
Art of making intelligent decisions through by analyzing data.
And that's what machine learning is.
Cleaning the data,
Huh?
cleansing the data, cleaning the data.
You cannot build a machine learning model without cleaning the data. So cleaning the data is a fundamental part of machine learning also. So what is data science? Data science cannot be just cleaning the data, right?
Structuring data.
All of that is included in data science. All of that is included in machine learning also. Structuring the data is part of machine learning also.
Break it, break the definition like this. What is data and what is science? It, science is what process of making uh, process through which you were able to extract some meaningful information. And here, extracting meaningful information from data. That is data.
And you do the exact same thing in machine learning also. So this is what I actually want to get at. There is not much difference between these terms, but frequently and regularly you'll see these kind of graphs. Okay, these kinds of charts. Again, somebody has put data science around artificial intelligence also. Okay, and you see these kind of and I have conversations with people who believe in these kinds of things. They say, no, data science is the core of everything. Someone said, no, 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 machine learning is the core of data science. And when people are having discussions at this level, you should know that this person has knowledge at this level only. I don't agree with any of these diagrams. See, this guy is saying data science is a Venn diagram with all these things. This guy is saying data science is in the middle part of statistics, and in this side you have AI, and the middle part, collapsing part, is data science. This is all nonsense. Okay, data science is just all the tools that we use in machine learning. Okay, you can call them as part of data science. And many times, when you don't want to go all the way to build a model and deploy the model, you just want to extract the pattern. Like I said, machine learning model was able to extract the pattern. Let's say all you want is the pattern. So you can say you're basically doing data science, because to build a pattern, you need data. Okay. So fundamentally, AI and data science are different applications of the same thing. What is the core? The core is machine learning algorithm. So just remember the core, how traditional program works, how a machine learning program works, how a Gen AI program works. Okay. Yeah, this is an amazing diagram from the book that I mentioned. So machine learning is based on certain um, pillars, and these pillars are, so all of these are the tasks that I showed earlier: regression, classification, density estimation, very related to common term known as clustering. They're related, they're not exactly the same, but they're related. And dimensionality reduction. These are the pillars of machine learning. And the foundations of all of this is essentially these maths concepts: vectors, probability distributions, optimization algorithms, a little bit of calculus. Okay, I think we have
If I
exceeded
have to
the.
deep dive, this is the I know all none of this.
Yes. So in all our future sessions, we are going to touch these things just enough to understand the pillars. See, you can take a 6 months course on vector algebra, and then you can take another 6 months course on vector algebra too, right? So all of these are unending fields, but in these sessions that we'll have here in the Success Institute, we're going to touch all of these just enough to understand. Okay, all right. So we have kind of exceeded the time limit. Um, so if this is what we can take away from this session, the basic terminology that we have understood, I'll be happy. Okay, the definitions, and the most important thing, intelligence has to be built using learning. That learning is called machine learning, and that machine learning is nothing but learning patterns. And I think in the next session we can do a next session next month, where we'll talk about what these learning patterns are. In fact, let me take 5-10 more minutes. Are you guys comfortable? Are you guys comfortable to finish this?
Yeah.
Maybe another 15-20 minutes. Yeah, we'll finish introduction today. Okay, perfect. So we're going to talk about learning patterns. From all the past discussion that we had, this is one thing that I want us to take. What are we trying to do? We are trying to learn patterns. Okay. So the first question that comes is there a relationship between pattern learning, pattern recognition, and intelligence?
That is what we learned. That is the fundamental for intelligence.
Okay. Yeah, that's what I told. But what do you think? Is there a direct connection between? I said that the only way of becoming intelligent is learning. And what is learning? Learning is nothing but learning patterns. But do you agree with that? Do you have any other like proof that says that? I may be wrong. Okay. Have you guys heard of IQ tests? What do we do in IQ tests? Have you seen these IQ tests where you have to find the next pattern, right? In fact, to this day, we measure intelligence by the ability to recognize patterns. So there is a direct connection between pattern recognition and intelligence. Do you guys want to solve this? I actually thought of bringing chocolates, and the person who solves it first will get some chocolates. Yes, try to solve it. It's very easy. Take some time. 1 minute. Possible. Do we have chocolates? No.
How many?
So we're getting chocolates. Yes. Yes. Correct. Sisters, we'll get you a chocolate now. Okay. So what did you do to solve this? No. The answer was 30. Okay.
3, 4, and 6. Second.
Okay. Exactly. So what do you need to do? You need to recognize patterns, right? What is happening here? What is the pattern? One more for another one chocolate or maybe two chocolates. This is difficult. Jazakallah. One chocolate for the sister. Can you give? Sister who answered the question. Not for you, okay? Sister, one chocolate for you. Someone trying to solve this? No? You guys want to solve this? You're not even attempting, right? People, I think people are attempting.
4.
Is it
The larger number of recognition the pattern. Just everything
Is
is
it
filled
16?
with the shades of green.
No, but you're close. Try again.
6, 7.
12, 12, 12, 12,
Add everything.
12,
23.
12,
Add everything. 6
17,
plus
12,
7 plus 5.
No.
12,
Huh?
12.
No.
4 plus 8 plus 12.
What is the answer?
23.
4 plus 12 is equal to 24.
Perfect. Okay. I actually have one more. It's very tough. But if you guys want to do it, we are not here to solve these problems. But if you guys want to do it, I'll give you, and it's so tough, I'll give you 500 rupees if you solve this.
Yes,
Do you guys want to try? Do you guys want to try?
Yes.
Huh? Pakka? Okay. But not much time, okay? Maximum 2 to 3 minutes. Okay? Go ahead. You also have options.
Any question for this? This is actually hard. Wait. Wait a minute. Is it D? Is it D? Yeah. D. 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 My answer is A. D. Is it D?
You sure?
Yes.
100%? Or you're just
Yes.
guessing?
D.
He's right.
Me also D.
Yeah, you'll get 500 rupees, not chocolate. I'll give you 500, don't worry. So, yeah, excellent. Brilliant, man. Brilliant. Very good. Anyone else was able to solve?
Me.
Someone was saying D, right? You solved, huh?
Don't.
Nice.
That's A.
So we have smart people in the room. I was not able to solve this.
The pattern is.
Okay,
So if you
excellent.
see.
So see, this is what intelligence is, and this is how we measure intelligence even in human beings. Okay, and that's all what we need to do for a machine. The ability, we have to give it the ability to find patterns. Okay. Okay. So now I have one case study. I want you guys to think through it. So now suppose if we go through this step by step, you will understand what machine learning is exactly. Okay. Let's go through this. Okay. So suppose there is a guy who is looking for job, okay, and he has 3 years of experience, okay. Now what he does is he got selected, okay, and now he's having discussion with HR. Now before having the discussion with HR, he wants to know like what should I expect, what should I talk about salary, how much should I expect, right? All of us have done that. And what do? We go to website research, how much do this company has, right? So this guy also goes to Glassdoor and he searches for people having people what are the salaries that people get for this position, okay, and he gets this data, okay, he finds this data, and a lot of people have given, but the only data he has is one. There are people who have said, I have 1 year of experience, and for this position, this company gives me 30,000. Okay. And not just one person, multiple people have given this data point. So it's the average is 30,000. Okay. Same thing for two also, for 2 years. And for 2 years, that company gives for that position 40,000. And for 4 years, that company gives 60,000. Okay. But this person has 3 years experience. You said 50,000. What do you guys think? Like, what should he? What should he predict?
50.
50. 50. What else? Any other answer? Okay. Any other answer? He wants to know how.
48,000.
No, no, you said 50. Fine. Anything else? See, you guys took fraction of a second to say 50,000, right? And all of you understood that it should be 50,000. Okay. But now you have to understand. Let's try to break down what your brain did to come with that answer. Okay. Because it was not a simple plus and minus. There was a little bit of pattern finding here. Okay. 50,000 is right, actually, right? We all know that it will be 50,000. And see, our brother, he took a fraction of a second and he said 50,000, right? Even before I finished the question. So, how did your brain come up with that answer? 30, 40, 50, right? Simple pattern. A very simple pattern can be seen here. But inside our brain, what essentially happened was your brain created a line, straight line, okay, and that straight line looks something like this: one, two, three, four. For one, you're getting 30,000, 40,000, 50,000, 60,000. So 30,000 for 1 years of experience. You have years of experience here, and you have salary here, right? For 2 years, 40,000. You don't know for 3 years. For 4 years, 60,000. And you created a line. You connected the dots. And then you thought, what will happen if I extended this? Where will it touch? It will touch at 50,000. That's why you said 50,000. Okay. All this is very automatic and very easy for us. Okay. But we want a computer to be able to do this. Okay. We want a computer to, when it does not, we see, we don't have a pattern. The company did not give us a pattern that this is the formula. Essentially, this line can be broken down into a simple formula: y is equal to mx plus c. Simple formula of a line. We are studying in 8th class, 9th class, 10th class, right? Here m is, can someone guess? What is m? Yeah, the slope. I think it's 1,000, right? 10,000, right? And c is 20,000, correct? You put this into this equation, you can get the salary for any years of experience, right? Now it doesn't matter. Once I have the formula, this data doesn't matter to me. Now you ask me, you want for 5 years, 6 years, and I can, based on this formula, I can give you. Okay. So the company, the on Glassdoor, did not give you this formula, right? It only gave you this data, which you were able to use. So you, in your brain, you actually do two things. First, you found a pattern. Okay. So you remember this is how machine learning program works. This is how traditional program works. Okay. Simple, nothing new. You did something. You found a pattern. You had the input, you had the output. What is the input? The input was years of salary. Okay. Sorry, years of experience. Okay. That's your input. What is the output? The output is the salary. So you have inputs, you have outputs. So see, you're getting both of them, inputs and outputs both. Okay. And then you thought, okay, let me find a pattern. What is the pattern? And you found this pattern in your head. You found this line. You found this equation, whichever format, doesn't matter. Sometimes it's it's uh, it's not even one of these. It's a probability distribution. Even that can be a pattern, or business logic can be a pattern. If else rules can be a pattern. All of these are different forms of patterns. And then you did another step in your head in that fraction of a second. What? You use the pattern in a normal program way. Now you got a pattern, right? You found the pattern. So you use the pattern and you use the new input. The new input is 3. You want to know what I should want, what should be my salary if I have 3 years of experience. And you use that 3 and you got the output salary. Okay. So you did all of these things in a fraction of a second. See how it involves not just machine learning program. Machine learning program can only give you the pattern. That's not the end of story. You then need to deploy the algorithm and you need to use it. Use it for inferencing, use it for prediction. And this is how you use it. You use the pattern. And you did both of these things in a fraction of a second. A machine learning, a computer cannot do that. And we want to give it the ability to do this. Okay, that's what machine learning is. That's what pattern finding is. Okay, so this is essentially what machine learning is, the entire process. The first part that you saw, you have input, you have outputs, okay, and many times not just one, you need multiple, you need hundreds, you need thousands. In this case, you were able to do it with just 3 data points, okay. But most problems in the world are not that simple, right? Most problems in the world are more complicated. We'll see some of the examples. So you need more data points. So you need both the input, both the output, okay. And you use this kind of finding pattern kind of system to get this thing. The pattern, now I'm showing the pattern as a star because this is the star of the whole AI ML thing. That is the star. That is the pattern is the star. Okay. Yes. Okay. So the process which uses the inputs and the outputs to give you the pattern is called training. Okay. This is called training a model. You must have heard of this. They're training a model. They're training model. GPT was trained on thousands of GPUs for thousands of hours to get to the place. So while training, it was doing this. It was finding the pattern. Once you have the pattern, you can just use your new input to get the prediction, and that's your inference. That step is called inference. Okay. So most problems are not simple that you can solve with 3 data points or a simple linear relationship. Okay. Most problems are difficult. Have you seen this? Have you used Car Dekho to find the price of your car? How many of you have used it? So what happens when you what do you do? Before there's a new interface. Before it was not like this. Have you used the new interface? This new interface. You will enter your details, your registration number, right? And it will get all the information about your car, your model, your make, your year, when you purchase, when you all that data it will be there. Based on that data, it will try to tell what should be the price. Okay, now imagine instead of giving you years of experience and salary, I give you this. How many columns? 1, 2, 3, 4, 5, 6, 7, 8, 12 columns and the price. Suppose I give you this huge data set with 12 columns where I have recorded from some company, who sells old cars. They have given me this, that this was the model, this was the make, this was the age, and they sold it for this much. This another car, this was this model, this make, this, and they sold it for this much. So you have price with all these associated columns. Suppose I give you this, will you able to, suppose I want to sell my car and I come to you. Okay, I have this data of 10,000 cars and I want to sell my Maruti Ignis. Please tell me how much should be the best price. Will you be able to tell? Will you be able to analyze those 1,000 data sets? It is slightly difficult, right? So that is why we call machine learning pattern learning at scale. Okay, just add the word at scale because we can do pattern finding like we did. Like, even this, how old are you? 11. See, this 11-year-old kid was able to solve that pattern finding problem, mashallah, thanks to good genes, I think. Genes of intelligence. So, uh, but we will struggle with these kind of problems. How much ever intelligent you are, if I give you 10,000 cars with their prices, you will struggle to find, if suppose the car that I'm selling, you don't have any example of that car, but you still have to predict the price, right? How will you do it, right? So finding patterns in that huge data set, that's what the models are able to do. Okay, so pattern learning at scale is machine learning. Suppose, yeah, this is an example of the data set. Okay, so you have the name of the car, you have the year it was purchased, you have the selling price, you have kilometers driven, fuel type, seller type, transmission owner. This is a small sample. Something that car deco uses might have hundreds of columns. Okay, and this is what you're trying to predict. This is what you're trying to predict. So all of this is input, and this is the output. Okay, so you will always have at least one column for output, and all the other columns will become your input. And once you have the input, you have the output. You just need a machine learning algorithm that will give you what? That will give you a pattern. You can use the pattern to get the prediction for a new input, right? Something that is not even there in the data set, just like 3 years of experience was not there in the data set. But we are able to do it, and machine learning algorithm can also find. Okay. Another example is you guys have used this Magic Bricks, Propworth, whatever, these kind of apps where you tell everything about your property. It'll tell you how much it should be worth based on location, based on square footage, based on number of bedrooms, number of bathrooms. I don't know if I have, but again, the data set for this also looks something like this. It's huge. Sorry, it's huge. It has. I didn't add that, but hundreds of columns, right? Square footage of the house, of the built area, of number of bathrooms, number of the location, so many things. Based on all of that, you have to tell the price. What should be the price? So these companies like PropWorth, Magic Bricks, and all these, they have this data set with them. They have this data set of millions of properties that have been sold. Okay, and that's why when you enter your little bit of details, you have never entered your house ever before in that app, but because it has all that data set, it will find the pattern, it will apply the pattern on your property, and it will tell you the price. Okay, these are typical examples of machine learning, right? Another example is spam filter, right? um, in all of our inboxes, we nowadays the spam filter has become so efficient that we rarely ever check our spam, right? But think about 10 years back, how somebody used to send you an email. You said, nahi mila, nahi mila, I didn't get it. Check your spam folder, it will be there. You remember, right? We used to do this 10 years back, but nowadays people don't say check your spam because the spam filter has become more efficient. It won't make those mistakes, right? But this is also another example. Now, it'll be slightly difficult to think about what kind of formula, we're talking about formulas, right? Or lines, right? Or these relationships like y is equal to mx plus c. What kind of formula can separate your spam? Can you can you think? It's difficult, right? So you have an email. What formula can you apply on that email that it will tell you whether it's spam or not spam?
Words and the relations.
Relationship between what?
It's a recurrence of the word.
How do you convert? So you have words. How do you convert words into mathematical formula? You need a formula. You need a pattern at the end, right? How do you do that?
Probability.
Yeah. So essentially, we one of the simplest techniques is just count the words, count the number of words, and um, so we are talking about hundreds of columns, right? In this case, you have a data set. I'm talking about a very simple example. You have a data set where the number of columns is 10,000. Each column represents a word of English dictionary. Every word of English dictionary, there's a column for that. And then inside your email, you will put how many words for that of that word are how many times that word came. So most of these will be 00000 because most of the English dictionary is not being used in your email, right? The specific email that you want to classify, whether spam or not. So most of them will be 00000, but dear, under dear, there'll be one, right? Under thanks, there'll be one, right? So you will get this huge matrix. You're understanding? Where you have each number
It's again a
representing
frequency distribution.
exactly. So this not really frequency distribution. The okay, the correct word is frequency matrix. You have this matrix. Distribution represents distribution slightly different. Distribution represents when uh, we actually use distribution for numerical quantities, like I showed you for heights. That was a frequency distribution. So, but yeah, the idea is correct. You are right. So we have this table, and then for each row, you'll calculate what is the if you have the data set, you'll have one data set for all the spam, one huge table for all the spam emails, one huge table for all the non-spam emails. Okay, and then for your email, what Gmail will do for your email, it will measure how likely it is that your email came from one table and how likely it is your email came from the second table. Whichever has the higher probability, it will classify as that.
The trick is constructing that master table because that's why it has taken so much time to make that.
No, that was not the challenge. This was easy. This was easy. We were able to do this very easily.
But to construct that master table, you will have to have enough data to reach to the point that this is the ideal baseline for you to check it.
See, Gmail had billions of emails. Gmail didn't have a data problem. They had huge billions of, but Gmail even 10 years back was not good, even with those billions of tables. It's just because what I mentioned to you is a very naive algorithm, a very basic algorithm. We developed better algorithms to find out patterns. That's all. Okay. Table was not an issue. Even at that time, table was not an issue. So we just calculate what is the probability that this particular email that you're getting comes from this table or this table, right? So if the probability of this coming from the spam table is high, then most likely your email is a spam and it should go in a spam folder. Okay. So so we saw some of these problems with unknown models. We don't know the pattern. If somebody could spend multiple years doing research and finding out what is the formula for like y is equal to mx plus c, the formula will be slightly complicated. It will be y is equal to y is equal to alpha 1 times mileage plus alpha 2 times fuel type plus alpha 3 times body type plus alpha 4 times model car company plus alpha 5 times something else. So all these, if you have a huge equation like this, if somebody could spend years of their life and find the equation that gives you the price, you don't need machine learning. But the thing is, no one was able to do it. It's a very challenging problem. But there are problems where people have actually spent years and found a mathematical formula, right? Like Ohm's law. Simple, V is equal to IR. It's a straight line, right? Same line that we saw with years of experience and salary. Somebody did the experiments and found this pattern, right? So you don't need machine learning to predict what will be the current given the voltage or what will be the voltage given the current. You don't need machine learning. Why? Because somebody has spent time and found the formula. The only reason we need machine learning is because nobody has been able to find a formula for the price of a car or price of a house, right? That's why we need machine learning. Otherwise, we don't need machine learning if somebody can do that. This formula, somebody spent years to find the formula for gravitation, right? Now we don't need machine learning to predict what will be the gravity at this point. We can simply use that formula, right? So machine learning solves this problem of spending years to find a mathematical formula, the relationship behind something, right? And the formula that the pattern that it finds is not 100% accurate. We have to assume that. There's a famous saying in machine learning, which is called uh, all models are wrong. All models are wrong. Some models are useful. That's all. We use them because it's useful. But no model is 100% accurate. Okay. All models are estimations of the pattern. The only way of finding the real formula is by doing this kind of research, like Newton. Okay, if somebody can do that for price, you'll get maybe Nobel Prize. I don't know if Nobel Prize, but some big award in achievement. If you can find the formula for car price, formula for house price, then the problem becomes very simple, right? These companies, they pay a lot to buy this billions of data sets, and then they use GPUs and CPUs to train on data sets to find the formula, right? And the reason today LLMs are expensive, training LLMs is expensive because nobody knows the formula of language. If somebody can give you that this is the formula for language, you don't need an LLM. But the reason we need LLM is we don't know the pattern behind, the formula behind these things. So finally, there are few different types of learning. Okay, have you guys heard of these terms? Supervised learning, unsupervised learning, right? Is there complete clarity in your mind? What is supervised? What is unsupervised? What is reinforcement? You have clarity? Tell me what is supervised.
Otherwise, is basically you have human in the loop while training the machine models.
Human in the loop is a big word.
Uh, no, there is somebody who corrects the output and sends the
No.
input while human
So the examples that we saw, what were they? Were they examples of supervised or not? Car,
which
car dekho example, or the years of experience example. Is it supervised or what?
I think it is.
Not
I, will-
supervised?
I will I'll say it like this based on my limited knowledge. Start with supervised and you evolve uh, to unsupervised.
No, there is no such thing. Supervised is a different type of learning. Supervised. Any more people who have heard of these terms at least? Just raise your hand. You've heard of these terms. You've heard of these terms? Supervised, unsupervised, reinforcement. No? Okay, most people even haven't heard. What have you heard?
Heard about this?
You don't know what it is. Okay. See,
I think unsupervised is correcting the errors automatically,
no,
huh? while while predicting the models.
no,
Supervised is you need some human or human experience to correct it.
no.
Is unsupervised like it's wrong?
Okay. So, see, the reason why I'm asking is because um, uh, most of the discussion uh, in AI ML starts with all these terms: AI ML, data science, Gen AI, and then it comes to these terms. Okay, and there's a simple problem in AI ML right now. A very simple problem in AI ML right now is AI speakers Do you agree? Do you agree? Can you can you understand my handwriting?
It's based on individuals.
No, what I'm saying today in AI/ML, AI speakers, number of speakers who speak and talk about AI is more than the number of experts. Do you
Or
agree?
greater than.
Yeah, greater. Sorry, that's a greater. You agree?
Yeah.
There are more people talking about AI and ML than than even the experts. And I'm saying this because I have attended a lot of talks in our circles and where some guy will be talking about AI. They'll be using all these terms, and I have seen more people giving the wrong definitions than the right definitions. Okay. The problem is this because there are more speakers than the actual experts. So that's why I want to clarify these terms. Okay. So the different types of learning. These are the three. There are actually more. There is something known as semi-supervised learning. Okay, which is somewhere between supervised and unsupervised. There is something known as federated learning. You guys have heard of federated learning? Huh? Huh? Sorry? Super annuated learning. That's something very small and very specific. General learnings we're talking about. Okay. There's something known as active learning. So these are all slightly more specific and more specialized. I don't want to talk about them. These are the main types of learning. Okay, supervised, unsupervised, reinforcement, and it's absolutely essential to understand the difference between them. Okay, so let me use the board. We saw data sets, right? We saw a one simple data set where um, say this. There was input, there was input in one column, and there was output. Which data set looked like this? Input out. Huh? Yeah, that's salary, right? That salary data set was something simple like this. Years of experience was the input, and salary was the output. Correct. We also saw car, house, and those examples. What will they look like?
Parameters.
Multiple input columns and just one output, right? So we have seen two types of data sets, right? Whenever you have data sets that look like this or this, okay, you are doing supervised learning.
Okay.
Okay. Sometimes you will have data set which look like this. What is missing?
Okay, I can connect.
If your output is missing, what can you do? You can only do unsupervised. Okay. The word supervise actually means the presence of output. If your output is present, that means you have supervision, something to supervise the learning. That means you have the correct answers. So it's like giving a test. Before a test, you give a question bank. The question bank has right answers and the questions and the answers, right? That is our supervised learning.
I could
Yeah. Okay. And sometimes you have open-ended questions, right? You have the question and the teacher says, there is no wrong answer, just give me the answer. Okay. In those cases, you're doing unsupervised learning. Okay. We will see in detail what kind the examples of all of this in some session maybe next month. But we'll see in detail all of these things. How do you train a supervised learning algorithm? How do you train an unsupervised? What is the application of supervised learning? Where can you use supervised learning? Where can you use unsupervised learning? You can't use both of them. So um, you saw spam filter. Spam filter is an example of something known as classification. Okay, in fact, I think so. So I'll come to reinforcement learning also. So classification is when you want to classify something, right? This is a classic case of supervised learning because you need to know the examples of spam emails. You need to know the example of non-spam emails, right? When you have those, you have the answers also, correct answers also, then you can train a simple classifier based on supervised learning. Regression is every time you want to predict a number, it's called regression. So we have x, we have input, we have output. Okay, input can be many columns in input, right? If your output is like a word, spam, non-spam, okay, or even if certain specific categories like small, medium, large, if your output is looks like this, you have to do classification. Okay, if your output looks like a number, like we did in our first case, 30,000, okay, or the price of a car, 5.4 lakhs. If you have these numbers, then you're doing regression. That's it. So we saw examples of supervised learning. Supervised learning is every time you have output, you're doing supervised learning. The type of output will tell you whether you're doing classification or regression. Now, suppose you don't even have the output, then you cannot do supervised learning. What you will need to do? You will need to do unsupervised learning, which are things like clustering and density estimation. You saw in the pillars, one of the pillars was classification, one of the pillars was regression, one of the pillars was density estimation. In this case, either you have the output but you don't use it. Many times I have the I'm not using it. I'm only using these. So I'm doing unsupervised learning. I'm doing clustering, I'm doing density estimation. And sometimes you don't even have the output. So you cannot even think of doing supervised. You can only do unsupervised. Okay. And the other pillar was dimensionality reduction. Dimensionality reduction is just so I told you the car dekho example, it will have hundreds of columns. Okay. Suppose for some reason I don't want to use hundreds of columns. I want to use only two columns. I can do that. I can compress all those hundreds of columns into two columns. What will those two columns? I'm not removing the columns. I'm compressing them. So it's basically compression techniques. All compression techniques work on dimensionality reduction. Dimensionality reduction is nothing but compression techniques. Why do we need it in machine learning? We need it because, like I mentioned in the spam filter example, you don't have 100, you don't even have 100 columns. You have 10,000 columns. You have 100,000 columns. Imagine spam filter for our emails. We even use Hindi words. So, just using English dictionary words will not work. So you need millions of words, right? Imagine all the languages, words of all the languages. Now you have to tell whether the email is spam or non-spam. So now you have millions of columns. Now your challenge becomes real. Now the matrix is even too big even for Google. So what they will do? They will compress. They will do this. Okay. So this is what allows us to solve big data challenges. It's extremely essential. We can deal with 100 columns, 1,000 columns, 10,000 columns, but when it comes to millions and billions of columns, we need this. Okay. So few things, right?
So
Supervised.
can you tell me briefly the concept of unsupervised learning where you don't supply an output and how the
Good.
algorithm is able to predict
Good
that
question. Yeah. This question. Yeah. Always. This question always comes. Uh, so yes. So I supervised is clear, right? Supervised is clear. Now we'll see unsupervised. When you don't have an output, the example, good example is um, you have those in your inbox. You have promotion, social. Nowadays, you have seen that tabs. Did you create those tabs yourself? No, right? Gmail created themselves. You know how they did it? They they didn't use supervised learning. Somebody didn't sit and said that these all these emails should be promotional, all these emails should be. They what they did was they used unsupervised learning. They took all the emails, okay, and clustering is essentially you have all the emails, you have all the rows, but you don't have any output. All the emails are same only. There's no difference between the. It's not like this is spam on this. There's no label, right? There's no output. But then if I if I plot them in it's actually plotted in high dimension space, but to explain I will it's plotted in, let's say, in two dimension space. All these are plotted in two dimension space. You will start to see that some emails have similar kind of words, some emails have different kind of words, so they're slightly different. And when I look at them I can see clusters. There is no output, I don't have an output. But just by looking at them, by just by plotting them in some high dimension space, I see that some emails are coming closer, connected to closer. Some emails are forming their own groups. So clusters are like, even we have friend clusters, right? Few people, they're close friends, they always stay together. Some other friends, they stay separate, they form clusters. These clusters, they don't need labels, they're just there. They're part of the internal data. Those clusters are part of the data. You don't need any label to tell that this is a different cluster. Just by looking at it, you'll be able to see the clusters. One example is this. The other example is
So when you said the dimension here in this context, it can be number of words. Uh, it can be
oh, these dimensions.
yes, yes.
Mm, see, technically, these dimensions are something that we call as principal components. They don't have any meaning. We just plot them. We so suppose I took that 10,000 thing. I do dimensionality reduction, okay, and I reduce it to two dimensions. Those two dimensions don't have any meaning, but when I plot them, you'll see some clusters form. These dimensions.
That's fine, but
Yeah.
how would you plot them? Because the dimensions is essential, right? So on what basis will you detect the dimensions? Like
So
for example, for the spam thing, or even that clustering of the mails, right? So what would be the dimension used there?
yeah, see, I'll tell you. In our spam, the all the columns are representing words,
Correct.
right? There are 10,000 columns. We'll talk about how dimensionality reduction compresses all of that 10,000 columns into two columns. If I do that, okay, in fact, one of the sessions, we will do this ourselves. We will look at images, okay, images of handwritten digits, 1, 2, 3. What we'll do, an image is, let's say an image is 400 cross 400 pixels, right? This is an image, okay. The way you represent this in a machine learning model is using 400 into 400 columns. How many columns is that? 16,000, 160,000, 16,000, right? 16,000 columns. Okay. 16,000 columns are there. We will do it in Python. What we'll do, we'll convert this 16,000 into two columns. These two columns, they have numbers in point 1, 2, 3, 1, 2, 3, x values, y values. They have these numbers inside them. These numbers have nothing to do with the image. This might be an image of a dog, but somehow this image of a dog is represented, compressed down to two numbers. That's it, two numbers. This whole image is compressed down to two numbers. Those two numbers might look like 0.145 something, and these two numbers 0.254, whatever. These two numbers represent my image. Okay. Now can I plot these two numbers?
Okay, as long as there is a reverse traceability to how you are detected this.
Yeah, you can reverse it. Obviously, you can. You already know that this is image number one. Image number one is reduced to these two numbers, and I can plot these two numbers. 0.24, 0. Will be here. So this image becomes a point here. Same thing with text.
So essentially, you will not go more than 3 dimensions at any point in time because
No,
you are reducing it, right?
no. So I'm showing to show you.
Ah,
Okay. Even when we'll do it in practice and exercise, to see the figure, we'll reduce it to 2 dimensions. But when you want to do clustering, you can do it in 100 dimensions also. But there you cannot see what is happening. What you can do is you can calculate distances between points in a 100 dimensional space. Okay. So suppose there is a simple formula to calculate. This is a point in 2 dimension. This is another point. This is another point in 2 dimension. We know there is a formula to calculate the distance between these 2 points.
yeah, I'm now getting it. So if you look at the large language model, the text model especially, you will have similar dimensions and the relationship between the words.
Yes. What you're talking about is, I think, embeddings,
I don't
word
know the
embeddings.
technical term, but I'm trying to relate.
Yeah. So large language model actually build a high dimension space, which is millions of dimensions, and one idea or one sentence represents one point in that space.
And the relationship between
Distance between two ideas is the distance between these 2 points.
that's how it is able to predict based on the
Yes,
nearness.
yes,
Nearness to
yes.
the
In high dimension, so I was talking about a simple formula. The simple formula between for this is y is equal to x2 minus x1 square plus y2 minus y1 square, right? You must have studied this distance between 2 points, square root of this. Okay. This is simple, it's called Euclidean distance. Simple way of finding the distance between 2 points. I can apply the same formula even for 100 dimensions, although it doesn't mean anything for us. We can't see what that distance looks like, but it will give you a value. So you will have so x1 2 minus x. So basically, let's say x1 1 minus x1 2, x1 x2 x3 x4, all the distance in all the dimensions, square them, square add all of them, square root them, you'll get a value. That value represents distance. We can't see that distance, but it represents distance.
yeah, makes sense.
Okay. So this is your doubt clarified? How we can see clusters? So we don't always reduce to 2 dimensions. Even in 100 dimensions, we can get an idea of clusters. How these things are close, these things are far. Yeah, it's very abstract. But the algorithm will tell us that this is, you can ask it, this is my point, which cluster does it belong to? It will tell you it belongs to the cluster to which these points belong. Those clusters don't even have a name because giving a name means giving a label, right? Okay. So supervised learning, unsupervised learning.
Everything has a logic. That is the greatness of Allah. Actually.
Yes.
Anything you can predict.
Yes. Cool. So supervised learning, when you have output, when you don't have output, unsupervised learning. What is missing is reinforcement learning, right? Any ideas on what is reinforcement learning? Last topic, we'll close.
Forcefully,
Forcefully. Nobody learns forcefully. Actually, lot of instructors of AI get confused between supervised and for this supervised and reinforcement. Lot of instructors get confused on supervised and reinforcement. Yeah. How many people have heard of reinforcement learning, especially with LLMs and all that, right? LLMs are trained on reinforcement learning.
I'm just getting it related to reuse.
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 There is a feedback. Somebody was talking about feedback before, right?
Optimization basically is like go by just by the
Optimization is a very general term.
yeah.
Everything is optimization.
I mean evolving the model by what do you call improving the accuracy of the model by reinforced learning by I mean as you said
By
by
feedback.
feedback
Improving the model using feedback.
feedback loops we call it in
Feedback
systems thinking.
loops. You can do supervised learning using this. You can improve a supervised learning model using feedback. How is the supervised different from reinforcement learning? I mean, we do it even in our company. We have a model that I have built that is running, that is deployed for our clients like Domino's and all these companies. And over time, it starts performing worse. So we have to retrain it. We have to make it better. We have to give it feedback. So even supervised learning model has that. How is it different from reinforcement learning? No? Okay. Um, so you saw what makes supervised learning? Because you have the output. If you have the output, it's supervised learning. If you don't have the output, it's unsupervised. In reinforcement learning, we don't have the output. So in some sense, now it's like unsupervised learning, right? But then we are talking about reinforcement, and reinforcement means there is some feedback. Okay, so there is no label, but there is feedback. Can you tell how this can happen? There is no right answer. I will not tell you the right answer, but I will still give you the feedback. Can you do that? If I give you the right answer, I'm using supervised learning. If I don't give you the right answer, I'm doing unsupervised learning. So now I'm not giving you the answer, but I'm giving you feedback. That is reinforcement learning. Huh?
Prediction. Expected.
Prediction. What do you mean by prediction? Prediction of what?
Based on existing pattern, we take this as an input and modify the pattern.
So you got the prediction from the model. What will you do with that prediction? How will you give the feedback?
I think you will connect to the user experience. I mean, somewhere you have to connect with it, right? See, for example, in that classification of different clusters, right? And as a user, I should be able to provide the feedback.
That's fine. You can provide feedback, but you cannot provide correct answers. If you provide correct answers, it is supervised learning. You're not providing correct answers. So what kind of feedback are you providing? Expected answers means correct answers. You're not giving correct answers.
Something which is close to the correct answer.
Okay, but no, not right. Okay, I gave you examples of tests, right? If I give you a question bank before the exam that learn these questions, the correct answers are also given. You're doing supervised learning. You're like uh, in our schools, they give us example questions before the exam, right? Example questions. Prepare the exam will have questions just like this, right? That is supervised learning. When they don't give the answers, that is unsupervised learning. But what is reinforcement?
I'm just thinking, guessing. We have a process.
Open book. That is unsupervised.
Like giving
I think it is about validation mechanism. You don't use one method to come out with an answer. Instead, you use two or three methods and compare the answers and see whether that is That way, it will be a feedback.
No, it's much simpler than that.
Uh,
You're making it more complicated. It's much simpler. How can you give feedback without giving the right answer? Can you do that? Don't we do that all the time? Giving feedback without giving the right answer.
improve.
Like,
Can you improve?
I'll tell the answer. When you want someone to learn something and you don't give them the correct answer, but you just tell, no, 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 that's wrong.
Right or wrong?
Exactly. Right or wrong. The correct answer is right or wrong. You only tell the model whether it is right or wrong. You don't give it the right. You don't give it the answer, the right answer. It'll give some prediction. You will just say yes or no. No, that's your feedback, right? Saying no is a feedback which the model realizes, oh, I made a mistake. I should change and I should give a different output. Again, it will give an output. You'll say no, again, you're wrong. Again, it will try something. You'll say no, wrong. Again, it will try. Once, after all these times, it will give a right answer. You'll say yes. Then it will, oh, okay, this is the way.
Which means that you get the pattern for
Yes.
getting it right.
Yes, yes. So these are all pattern learning techniques, but different ways of learning the pattern. One was where you gave it the correct answer. One was where you didn't give the correct answer, but the pattern that I want to learn has nothing to do with answer. It's just I want to find the pattern in the questions. When you want to find the pattern in the questions, you use unsupervised learning. But when you wanted to find the answer, but you don't want to give the correct answer, sometimes you don't even have the correct answer, but all you know is no, it's doing something wrong. For example, when when you remember when your child first started learning to ride a cycle, or even when you started learning to ride a cycle, and suppose you're teaching your child how to ride a cycle, how much can you guide? How can you give them the right answer? Can you tell them no, the right way of cycling is this, or will you say that no, no, don't ride like this, try this, try that, try this, try that? Are you able to give them the right answer, the right way of riding a cycle? Or
Yes.
you're just able to tell them that, no, right, no, yes, no, yes. Think about it. You can't give them the right answer. What is the right way of riding a cycle?
Showing the
You,
action.
showing is fine. You can show them. But you can't tell them that you have to move your left leg 90 degrees to the right and then move the right. They have to learn this on their own, right? Sorry?
You can understand. After some time, they will understand the balance of the
Evaluating the
cycle.
approach, not
Not the approach, you're validating the answer as well. You're just saying right or wrong. Okay. So that's it. Hopefully, it was of some benefit to all of you, and some fundamental understanding was gained during these lectures. I'm sorry, I think we overshot by many times. But this was just the introduction. Okay, we'll have many more sessions to come. I already showed you. We are going to cover all of these topics in detail. Um,
this should have IT background.
no,
General.
no, you don't need any IT background. We are going to many times we'll learn how to do it in code. But as I told you, I am not more interested in teaching you how to do things, but rather the mathematical intuition. Why? Because mathematical intuition is the power that you can have over people who will come and say that AI se ho jayega, AI se ho jayega." That's the only thing. I want you to have a mathematical intuition by which you can say, I don't think AI can do this because I don't think maths is able to do that.
We need to find that odd one.
Sorry.
We need to find that odd one. So we will keep ourselves safe.
Yeah. Okay. So these are some of the topics. Because we're done with introduction, we'll next time do a session on history, on limitations. These are important topics, and then we'll start all of this. Many of these sessions will have hands-on sessions. You can, if you don't want, you can decide not to do hands-on, but it's good to do hands-on, and more intuition comes when you actually try things. When you try things and it works or it doesn't work, you intuition builds up inside you, something that I can't even tell you. I can't teach you the intuition. Intuition has to get built. Okay, so we'll do things and we'll also do the maths. Okay, so you get a full intuition by doing and by knowing the fundamental maths. Okay, that's all from my side. Thank you so much.
Very interesting. Yeah. Assalamu alaikum warahmatullahi wabarakatuh. Alhamdulillah. On behalf of Success Institute, I'd like to thank Brother Hamza for this wonderful session on artificial intelligence. May Allah reward you and increase you in goodness. Amen. And I have seen that this session was meant for only 1 hour, but we have passed more than 2 hours, and everybody is hooked to their seat, and it is so much interactive. So I think everybody has taken something from this session, and we'll definitely plan for next a series of session on this one. From brother, we are working on that, and the announcement will come very shortly on this one. Okay, so please stay tuned, and I hope you all will be interested in that session and that training. And another